I was very happy that you could give me the chance to speak here on smart cities, in the context of smart cities. And when I heard smart cities, and I'm talking about the circular economy, and me, myself, I'm from the Linz Center of Mechatronics, which is an applied research center. So we are shifting gears here significantly to going to something much more applied and, let's say, a bit more company related. But when I heard smart cities, I went to the bookshelf of my kids for this book. It's The History of a Street. And it's very interesting because it spots at a geographic location, and it looks at this geographic location over 15,000 years of time and thinks of how this changes. And at the very early days, 2,000 years before Christ, you see a village, and it's a very confined environment. So that's kind of the village as it is. And over time, until now, that's the same spot, that's the same river, that's the same boundaries. But of course, a lot happened, a lot more interactions, and from something very confined and that you could see and understand to something very complex that kind of popped out over here. And it's even, let's say, beyond the borders, it's kind of limitless. And if you now take the very confined environment, you take the limitless perspective, you see what the economy kind of drove us. And also over here, you see that's the usage of materials and of energy that we do. It's kind of, in the sense, limitless. So we are going off and off, and you see the aluminium, the cement, plastic, steel usage, and it's all increasing over time. And since we are having a limitless use, we're coming to a dead end or some situations, just like the climate crisis, as we all know. And on the left over here, you see the global temperature rise and how it's expected to be, and what ways we could do to narrow it down, to lower, to change our behavior, to lower it down to levels that we could, as a society, somehow in a better way deal with the changes that we caused and the global warming effect. And one of the remedies, one of the tools that we have to use the materials in a better way is circular economy. And if you speak of circular economy, the circular economy butterfly has to come up. So here it is. I guess you might know it. So the circular economy means that you have some finite materials. From top, you produce them and they end up with the user. And the idea of circular economy is to keep them in use as long as possible. So at the beginning, this means repair them as long as you can. If you can't repair them, change the material or the product in a certain way such that it could be used in some kind of other way or usage level. And if this is still not possible, then maybe the materials, at least, they shouldn't go to landfill, but they should be reused and recycled to some extent. This is if you go to materials, and the same applies to renewables and biodegradable materials. So that's this kind of famous butterfly picture over here. And this kind of sketch of the concept also boils down in 9 strategies, what you can do if you want to prolong the usage of a material once it's created. And here I depicted it, but it's essentially 3 ideas. First, we use less. Try to use less. Simply, if you have, let's say, a one-way plastic spoon, then the best idea is to not need a plastic spoon. But if you still need a spoon, then maybe make a spoon that is reusable. It could be used for longer, for more often. And then if that's still at some point it's broken, then can we still reuse the material it was made of and recycle this? So these are different kinds of concepts that can be used if you deploy circular economy strategies. So the question that we kind of have is, there are the problems. We know we have to change somehow the way we do economy. There are strategies like circular economy to address this, but why is it so hard for us to change? Why don't we just do and deploy circular economy? What's it? And there are a lot of effects, but one of them I would say is that the consequences are in the far future. So it's not an immediate response. You don't have instant gratification for the actions that you do. And what you start now just takes some time until it trickles down to yourself. But what if we had something that could give us the right answer, that could give us the idea on which horse we should bet to be successful? And please allow me for this reference. What if we had the sports almanac from Back to the Future, where it says, well, all the results of all the horses and the dogs and all the bets you can do, we can tell you in advance. So we can tell you that you're booking, that you're betting on the right horse right away. And that's actually what we as a society would need. If we would have it, then the change for us as a society would be very easy, right? I mean, there's nothing better than betting on a winning horse if you know it. Of course, that's science fiction. That was science fiction in the past. But the idea is, of course, valid, and this would, of course, make us change. And one way to understand that things can change and make us move in the right directions is by regulations. And here's one regulation. That's the eco-design regulation for sustainable products. It's from the European Commission, and it's here to help us as a society go in the right directions with means that should stimulate the economy and give us commercial economic benefits on the way. We will get to it. So the regulation, it's been around 10 years in preparation. It went just like 2 years ago. It was with it's in the European Union. It's been last year approved by the Council, this eco-design regulation, and it's about to be implemented in 2027-28. So the first products will have to be conform with this regulation. And which products does this address? It addresses a big variety of products from iron and steel, alloy, textiles, furniture, tires, detergents, paints, lubricants, chemicals, energy-related products with eco-design requirements, and information and communication technology products and other electronics. So for all these kind of products, you will have to have product-specific information on 17 different properties. So for all these products, you will have to say what's the recycled content of the product, what's the water usage and efficiency of the product, what's the reusability of the product, what's the repairability of the product, and how possible and how good is it to recycle or remanufacture the product. So in the end, for every product, let's say a chair, it will look like this. For every chair you can buy on the store, in any kind of store, you will get this some kind of ratings within all these 17 domains. And now users will be able to distinguish the products not only by design, but also in respect of those 17 perspectives of sustainability. So it's now up for the users to take their dashboards, whatsoever they have, to make a distinction between one product or the other. And of course, for some customers, this will mean maybe energy usage and efficiency is very important. For others, reliability is important. For somebody else, this is, of course, environmental impact and mobility for maintenance, refurbishments, durability, reliability. And again, for somebody else, this might be recycled content and the possibility for maintenance and recovery, I think this is. And this is not only important for some customers, but we know from, let's say, research that we did in the past, that if we have something like this, this will change the purchasing behavior of people. So this will actually change the dynamics and will have effect on the profits and the incomes of the companies. So if that's the situation like over here, that recycled content and the possibility of maintenance is important and people will change their behavior according to this, then this is a call for action for companies. This means they will have to change their product or the way they produce their product or they do something with the product. So this is the customer side to itself, but also the regulations of the financial market. And this is something that we also already have. They could simply say, well, that's the threshold. You will have to have this kind of thresholds of your products. Otherwise, you have to pay more tax. You don't get the loans or funding that you want. This is something that you have to do. And now something really interesting happens, so to say, for the companies, because if you think about repairability, that it's over here, it's not so easy to do this. How would you change repairability for a product if you just used to produce it? Let's go for some specific product, just as an example. A product that we in our research center know a lot of, it's the electric engine. We know how to do an electric engine. We design it for a lot of customers. We can, within our vicinity of our company, can optimize the product in terms of certain qualities. But with this regulation, now we will have to optimize the product or do it on properties that we have pretty much no knowledge of. This could be some knowledge of other companies. We are not the ones who repair them. We are not the ones to recycle them. We are not the ones to do CO2 footprinting and so on. So the question is, how do you do this? Because if you take this product over here and you have the demand for repairability, your product depends on your suppliers. And their suppliers depend on their suppliers. And those are all the products and the process in this way changes. So if you want to change a complex product as you have it over here, then you need to do a cross-company product design because you can't do it on your own. And let's go back to this electric engine design that we have in our company. The electric engine design is made out of digital twins, digital representation on every stage, but this is here not digitalization of the behavior of a human approximation, but it's the representation of a mechanic or electrodynamic process. So something that can be described in a bit more precise manner, if you allow me saying so. And you have a digital representation to this. It looks something like this, and you can create and run simulations, and you get, let's say, what is called the digital product passport. You get some certain number. You should or need to get some numbers on CO2, balancing, durability, reliability. And if you don't know this kind of information within your company, then you have to go across your company boundaries to somebody else. You get the knowledge on what's the ability for upgrade. So I have to have a tool, the digital tool that asks this information from the others and get it back into my system. And then I get the approval and it says, well, the ability for upgrade is here. Everything is fine. So, but what happens if you need some other kind of information like the CO2 balancing and it says the value is not good enough for your company? How do you then change? Because you don't know, there are so many effects. There is the supply chain, and you could do so many different parameter settings, and you don't know what's the consequence on the CO2 balancing. So just doing it once will not help you. You will have to do simulations and optimize this in terms of CO2 balancing over and over and over. So this will bend this linear process into a cycle. You would have to do simulations and you would have to involve all processes for this simulation in an optimized fashion. So you would run, and that's what we currently do, 10,000 iterations of simulations a day for this creating this electric engine design. And at least now it's so obvious that the CO2 balancing, the knowledge that you need to do the simulation needs to be there automatically, because you have no idea how an external would calculate your CO2 balancing, but you need this information to create this electric engine design. And that's very, very important aspect. We have this within our company. We do the electric engine design for years, and now that our customers say, well, and now optimize it for this kind of certain CO2 value, because that's what the board of directors says. And then we say, well, we cannot. But if we can deploy external knowledge automatically and include it in our design process, we can optimize a design process in this regard. And now it's only CO2 balancing, but of course, as we heard before, it needs to be there for at least 17 other properties as well. So now this means for a user that has to do this not only in the electric engine domain, but in pretty much all other domains, the steel, tires, chemicals, ICT, and so on, you have users front ends, which is companies that have to optimize their product in a domain that they are not expert of. So somehow they need to get access to this optimized knowledge of externals. And how could this now happen? So you would have to have a front end, a digital tool where you enter your system requirements. You would need to connect to digital entities and digital representations of knowledge, like the CO2 balancing, like the digital twins for the electric engine design. Then you create an executable workflow. So a tool that allows to run this in terms of, to execute this, to make a solid representation of what you in the end want. And then you need to have an optimization environment where you run this over and over again, and you provide an answer. So to some extent, this is far-fetching and visionary, but actually a lot of the elements along the lines are already there. The front end, I mean, this is, we all know this by now, it's generative AIs, it's LLMs. There are quite some out there. They can do a lot of things. For now, they are not liable for what they do and the results that they provide. It's just an idea, but it's not something that you can really build a product on. And for this, you would need approved digital services. So you're somebody with a liability to it, that the information that you get, you can rely on. So we do for automotive companies, we design the engines, and they have the certain CO2 footprint demand. And if in the end it turns out the product, that the engine that they include in the cars is not as good as expected, then they're going to sue somebody. And then he will sue us, and we will say, well, we just did it as good as the data that we obtained. Where did you get the data from? Well, some CO2 balancing company. But who is this? We need to have a liable entity in this regard. And this is done via initiatives like the Gaia X or framework. Fiber is also going in this direction. There's the API economy that addresses this aspect, and there are lots others. So far, they are there because they have the idea of representing knowledge for external use, but the application case of circular economy has not yet come up for them as a big use case, but it will be, at least as long as the politicians and the requirements, the regulations are going to be implemented as designed and as demanded. Executing workflow. Here we have the orchestrator tools that need to combine those digital available knowledge representations and combine them with make workflows with this, and then we need runtime environments to let them run. And this overall will provide us an ability to create new kind of designs for a more circular economy and circular environment. So in order to conclude, I would like to show you a roadmap. So in order to encourage circular economy, we need to convey business models. We need to convey to companies that that's actually not a compliance tool, but something to make business with. And we are doing workshops with companies that they take half a year, 1 year, even longer, where at the end the companies realize, oh wow, we have to take circular economy from compliance to business. But that's actually the idea. I mean, that's the idea. Well, you have this sports almanac that the circular economy, the eco-design regulation is already bringing you on the path towards this sports almanac of knowing what we need for the future. And once you know this, there are the necessary technologies there to overcome here the system boundaries and develop projects for a new value creation environment in this regime. So I'm finished. I hope you have some interesting remarks, and I would be very happy if we can continue discussing on this now or later. Thank you.
Absolutely.